In this final exercise, we'll pull together the various parts from previous exercises so that we can check for clashes within our drainage design. So what we have here in our 3D model is our storm drain system, which we created earlier in a 3D model. And in a reference file, we have the water lines and gas lines that we modeled earlier. We want to check to see if there are any clashes between the water and gas with our storm pipes. So I'll use our clash detection tool, which is based upon the Microsoft Navigator clash detection tool. First, let me check the global options. The merge tolerance is a new feature in this tool that you don't see in Navigator. And so let's consider, for example, that this gas line that you see near this storm sewer it may clash with the storm sewer multiple times, all in this same area. We really want to manage those clashes as one incident, and so we can set a tolerance that if it finds multiple clashes within that tolerance, that we treat it as one clash incident. We can set a terrain model to determine the ground elevation, or the top elevation if you will, of the clash object which is created. And we can set the feature definition for any clashes that are found. So what we want to do is we want to check all of our storm sewer feature definitions. And we want to check those against the gas lines and the water lines. On our storm sewer, we'd also like to put a soft clash distance within the storm sewer, and so if any gas or water line is within 5 feet, we want to be notified of it. If we had trenches, and we don't in this data set, you could also use the trench as the soft clearance. So now we've got everything populated properly, we can run and process and search for clashes. Now the clash detection has finished running, and you'll notice some new features in our model. These are modeled as a red sphere, and that's because of the feature definition that we asked for the clash detection tool to assign. And so you can see the feature definition is set to new conflict. We actually create a 3D object, a 3D feature in our model, and that gives us certain advantages of, first of all, how to visualize it. And so as the status of this clash element changes, we can adjust the feature definition and thereby get a different visual perspective. And so, for example, we could use this feature definition that I defined that's called bore pit required, to give us a visual cue that there will be a bore pit needed in this area. Also, by creating 3D features, gives us advantages for viewing, reporting, querying against those objects. And so, for example, we can review a table of all the conflicts that were found. This table gives us some advantages, such as being able to review all the attributes of the clash and then navigating in the view to where that clash is located.